we'll see a problem on projection of lines inclined to both the planes. This is the question in front of us. The distance between the end projectors of a line AB is 35 mm. The line AB is 70 mm long and is inclined at 30 degree to HP. The endpoint A is 10 mm above HP and 20 mm in front of VP. Draw the projections of the line AB. So this is the question. So here first I'll note down the data. Distance between the end projectors of line AB is 35 mm. I'll write it down first. Line AB is 70 mm long. So that is the true length of the line, which is TL of line AB, 70 mm, and is inclined at 30 degree to HP. Inclination with HP is seen in VP and denoted as theta. Then the endpoint A is 10 mm above HP. And is 20 mm in front of VP. Draw the projections of the line AB. So this is the question in front of us. Now here 5 parameters are given which are essential to solve the problem. So starting with the solution part, drawing a light line. Next, they have given something about point A. So this distances, I'll note it down here. Point A is 10 mm above HP, 20 mm in front of VP. Point A dash and A. Ten mm above HP, 20 mm in front of VP. Then the distance between the end projectors are given as 35 mm. So here I am marking the distance between end projectors, which is 35 mm. Then the inclination of the true length is given as 30 mm. It is with respect to HP, so it will be seen in VP. For that, to A dash, I am drawing a light line, measuring an angle of 30 degree. With HP, it is seen in VP. Getting a light line, inclined at theta is equal to 30 degree. Then the true length of the line is 70 mm. Measuring the distance 70, keeping it on A dash, cutting this line. So here this will give me the point B dash, or I'll write down B1 dash because that is the true length. Next, this true length, now I'll draw a horizontal line through point B1 dash. Locus of point B dash. Then where this line is cutting the distance between end projectors, that will give me a point which is point B dash, and then joining B dash with A dash, it will give me the actual length of the line in the front view, will be called as EL. So here I am getting this actual length of the line. I'll make it dark. Then here is the true length of the line. Then similarly I'll have to get the true length and the actual length in the top view as well. So for that, projecting a light line, bringing B1 dash over this horizontal line, that will give me the point B1. Next, I need to get the actual length of the line in the top view. Like in the front view it is A dash B dash, in the top view it will be AB. So for that I am keeping the point on A, measuring A to B1, cutting this end projector. Here I am getting point B, joining A to B. Next, through point B I am drawing a light line. This is locus of point B. Then to get the true length, here either I can measure the true length directly, or another method is to bring this B dash and make it parallel with XY, giving the notation as B2 dash, and then projecting it right into the top view. So that it gives me the point B2, joining it with A. So the true length are coming to be same. Then I'll make AB dark, A to B2 medium dark. Next, here is the inclination of the true length with VP seen in HP, that is phi, measuring the angle 45 degree. So therefore the inclination of the line with VP, it is seen in HP, is phi is equal to 45 degree. So this is the true length, 70 mm, even in the top view. Here is the elevation length in the front view, and this is PL, the length of the line in the top view, called as plan length. 35 mm, which is the distance between the end projectors, and with this the problem gets completed.